So we are going to be looking at the differences between linear, exponential, and quadratic equations or functions. So if you take a look at this, some of our learning targets: choose the function that model a particular type of data, write the functions to model that data, and compare functions and rates of change. If you take a look at linear, you're looking at a line. That's where linear comes from, the word line. Exponential, that's where something's growing really fast. So you're using a slow curve and then a very, very steep curve. Quadratic function has decreasing and increasing with a vertex. That's a maximum or minimum. So this is a quadratic function. So it's like, think of a ball that goes up and down, up and down. All right, so differences. So one way to tell if you have a linear function is the first differences are constant. So what does differences mean? It means the subtraction of the numbers. And exponential, they have consistent y values with a common ratio. Remember, the ratio is multiplication. So this is subtraction. Now, if it's quadratic, this second differences are constant. So you're going to subtract once. If it's constant, if it's the same number over and over again, that's linear. But if you subtract a second time and the second differences are constant, now you're looking at quadratic. So let's take a look at a couple of these just to kind of get an idea. So if you take a look at this one and you go between all the numbers here, what is happening? So 7 minus 4 is 3. 4 minus 1 is 3. 1 minus -3 is -2. So you're getting the same number over and over and over again. That is linear. We've done a bunch of linear stuff, so that should be review. And if you're taking a look at this one, you have -4, -2, and -2, -4. So just look at the pattern here, right? You have a vertex, repeat, repeat, so you know that's quadratic. And if you take a look at these right here, then you can see that this is -2, -4, and -2. So actually adding, but this is quadratic. Okay, take a look at this one. I talked about the ball being dropped before. This one actually gives a better example of quadratic with first and second differences. So if you look at this, you're thinking, these things have nothing in common. What is this lady talking about? Well, at first they don't. It's 16, 48, 80, and 112. And you're like, well, that's great, but I don't have anything in common here for a common ratio, so it can't be exponential. But then when you do it again, you'll notice it's 32, 32, and 32. First difference, second difference. If the second difference is all the same number, it is quadratic. Okay? All right. And this one, like I said, I'm going to go right back to this one real quick to show you the comparison of the two. This one I was telling you how it's symmetric, right? Symmetric. It mirrors it. So the answers are mirrored here and here. That's a really good way to tell it's quadratic. Here you can't tell that because you're not given the vertex. This one you were given the vertex. So you can't tell that, but you can if you do the first and second differences. So it's one way to determine that. So if you're comparing rates of change, it's how fast something's increasing or decreasing. Exponential increases faster than anything else, really. And linear increases through an average rate of change, whereas this eventually exceeds that. So when you're comparing them, you're comparing how fast something moves. That's what you're looking at. So if you look at this graph right here, I should have pre-done these, but I didn't. If you're looking at this graph, And the reason I'm making it like this is because I can look at the points and determine what I need. So that's why I put it like that. But you have -3, 2, -2, 4, nope, 4, and -4, 4, -1, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then the same thing over here. So just by looking at the points, you can actually see this is quadratic. But just from the graph itself, you need to learn to be able to identify that. If you wanted to, you could set up a table as well. But you don't really need to because the points are given for you. So on this one, again, I'm determining where I'm putting the graphs based on where I see the points at. But I've already pre-done these, so I kind of have an idea. So -3, 1, -2, 2, -1, 4, 0, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 2, 14, which is off the graph. So if you take a look at this, it is exponential. Okay, a couple more. And again, I put the graph down here. And here. So I could just graph my numbers. I have 4, 0. I have 2, 1, 2, 1, 0, 3, -1, 6. So all the way up here. And -2, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see this is exponential. Okay. Exponential. Last one. This is a shorter lesson, so yay. So this is 4 up. I just did 4 up. And then I did 4 in going this way. And that's where I put my graph. All right. So then I can graph my points. 2, -4. That's how I knew to go 4. And 0, -2, -2, 0, -4, 2, and -6 and 4. Well, if you connect them, probably a little neater than I just did, but if you connect them, you can see this is a line, which means it's linear. Okay, that is all for this lesson, just recognizing by graphing the differences between linear, exponential, and quadratic. So it kind of ties in a couple of chapters that we've done. If you have any questions, please let me know.